in complex projects as well. So let's start learning. But before that, what do you think about Arduino is? Arduino is nothing but a basic, simple programming platform, and it can also be called a computer in a chip. It is a microcontroller which is used as a robotic platform in many countries, and it is really very famous. It has its own website and a big community on the web. So today we will be learning how to use Arduino Uno. Arduino Uno is used basically because of its high capacities. The storage is 32 KB and the processor is of 2 KB. That makes it quite good. And the clock speed is 16 megahertz. So today let's start. So I'm sharing my screen. Here is it. Here is it. So done. So now I am showing you how to start a code in Arduino IDE. Here is the latest Arduino IDE which I had downloaded, Arduino IDE 2.00000 beta version. You can download it from Arduino IDE, which I'm going to share the link in the description below. So let's start. So whenever you are doing any project on Arduino IDE, first thing you must need to do is to introduce a connection. So how to introduce a connection? It is pretty simple, using const, int, and the name of the connection. For example, if you are making a connection with the LED, you can write it as LED pin is equal to and the connection number. For example, LED pin digital point 13, then you can write 13, or else if you are connecting it to any other digital pin, for example, digital pin 10, so you can write that. It's completely your wish, friends. Or if an analog pin, you can write A0, A1, and so on till 5, because Arduino has only 6 analog pins: A0, A1, A2 till A0, A5. So now I'm connecting it with my favorite number, which is 7, and then a semicolon. Never miss to add a semicolon, because semicolon is a must. It differentiates between two lines of code, or else everything will be just a fumble. After this, we have introduced the connection, and then once the connection introduced, how will the Arduino board know whether it is output or input? You must tell it that this is the input, this is output. Most of the times when you are introducing a connection with a sensor, it will be a input, because we take information from a sensor. But here we are coming to a LED, so it will be output. So for introducing that, we'll write pin mode, then we'll be writing the name of the pin, and then it is a output. Done. So I hope this is clear. First, we introduce a connection. So here we have introduced as const int LED pin is equal to 7. So here we introduce a connection. The name of the connection, whichever you give here, should be used elsewhere. It may be void setup or void loop function. So whatever your name, whatever the name you give there must be used everywhere. You understand? You can give, for example, you give here LED, and here you give LED pin. The Arduino IDE app will show you an error that LED was not defined. This is what I'm telling. The name which you give here must be used. And once introduced, we will be starting to we'll be switching it on. So like you cannot directly write switch. Oh, sorry, switch on. Okay, you can't write simply switch on. There are specific functions. For example, now we are using a LED pin connected to a digital. So we must write digital write. That's a function. And now we should give here the pin name, LED pin, comma. Like here now I'm going to tell you what is the main logic. If you give here high, then it means that it will supply it 5 volt, constant 5 volts. You can also write it as 1, as 1 means the same. 1 is equal to high and 0 means equal to low. So we'll be practicing, but for now we will give high, means it will be supplying LED pin 5 volts. Okay, and then a special function. You might have heard it many. A person goes in a movie, keeps his leg on something or like a pressure plate, and then after some time, like 1 second, 2 seconds, suddenly a missile is launched or bullets are fired on him. How does this happen? How there is a time interval? All these electric time intervals are done called delay. And the delay, we must give the time in milliseconds. So like you might know what are milliseconds. 1000 milliseconds is equal to 1 second. So I want of 1500 milliseconds. So that's done. Now we will be switching off the LED. Digital, right? Now how to switch off, as I told you, give the pin name. Then to switch off, we will write low. Isn't it easy, friends? Then again we give a delay. Or what will happen is that I will tell you. White setup is nothing but a function in Arduino code which runs only once. As you can see here, I'm highlighting it. However, in void loop, once you put any code here, it runs in a loop again and again. You know it, right? Loop never ends. Again and again repeats itself. So if we are writing the code from here, so digital write pin high will run. Then delay 1500, that will run. Then digital write LED pin low, that will run. And from digital pin write LED pin low, it will again go to digital write LED pin high. This is how it keeps on repeating itself. So whenever you write code in void loop, you must be logical. Okay. So now we'll be keeping a delay, or else what will happen is that, as I told you, it will run a loop. The time it will switch off, switch it on again. So we must give a delay of 1500 seconds so that it switches off for 1500 seconds. Then it again switches on. Then it switches on for 1500 seconds and it then switches off. So this is what we have done today. We learned how to introduce a connection. I am giving comments beside this. Introduce, oh, sorry, introduce connections. So what is basically is introducing connections. If you are seeing this video, introducing connection is nothing but giving a pin name, what we have given here. Always remember, when we give a pin name, we have use the same pin name elsewhere. You can't write I give a pin name here and I will not use it elsewhere. This can't be done. Whatever you introduce must be used. Like, or else it will be undefined, right? If you don't know a person and you're telling yes, he's my friend, and if someone asks you about him, what will you say, right? So LED pin is equal to 7. We introduce a connection by giving it a name and to which pin it is connected. So we have connected it to digital 7 of Arduino. Here in setup, we uh, declare it as the output of our the LED pin as output, because LED gives out light and that's the output. So here we classify it as output. And whenever it is not necessary that you always write it as output, but remember one thing: if you are using a LED or any other device which gives the output, it must be written as output, and that too in capital letters. And if you are using a sensor, for example a flame sensor or ultrasonic sensor, then it should be given as input, because you are taking value from it, you understand. So then in void loop function, what we have done, we have switched it on, switched it off. So here I will be writing a comment that switching on a connection using using digital write function. So this is switching on and keeping a delay. Now here we switch off. I'm not explaining here, so please don't think that you are not explaining. But I am going to tell you how why have we have I'm writing this. Switching off a connection using digital write. function. And now the last, keeping a delay. Simple. So this is done. Now why have we have written all this in while loop? So in while loop, what like now in our this class we have learned how to introduce a connection LED pin, and we classified it as an output in setup because we don't need to classify it again and again as an output. Once classified, the pin is done. And then in digital write, we write it as digital write LED pin. So what's the pin name? LED pin. LED pin comma high. As I told you, high is equal to 1 and low is equal to 1. Please remember this. High is equal to 1, low is equal to 0. Like if you don't want to write high and it's wasting your time, you can simply write there as 1. Understand? And in place of low, you can write 0. It's simple. And if at all you don't want to write all that, you can simply write low and high and low are always used because they don't keep a conclusion. Okay, so first we switch on the connection, which is LED pin. That simply means that we have attached the LED to digital pin 7, and the negative terminal of LED is attached to ground. And we switch it on using digital write LED pin comma high. So we switch it on, then we keep a small delay, delay of delay of milliseconds, because we can't give here as seconds, and that is not in our hands whether to give it in milliseconds, seconds, minutes, hours, etc, etc. We must give it in milliseconds, so 1500. Then in digital write we switch it off because we don't want to completely, for example, if you want to keep it on you can keep it on, but now for illustrations I want to switch it off. So after a delay of 1500 milliseconds, I switch it off using low, and then I keep a delay. You might be thinking why I keep a delay if there is nothing in front. So I will explain you why I have kept this delay where actually there is nothing in front of this. The actual reason is that we kept here a delay. That is because this is a loop, and loop repeats itself. If I write digital write LED pin low and no delay, after digital write LED pin low, it will again repeat itself to digital write LED pin high. That means that it will not switch off. Understand? This is why we need to write delay 1500 seconds so that it switches off itself for 1500 seconds. And then it's over. I have given the comments and everything else. So this is how you must write the code. And this is exactly perfect code. I'll be saving this as okay in my Arduino project's code. Save. Done. Now I'll be opening the Arduino project's code. Where is it? Where is it? Sketch. Fun. Yeah, I'm opening it. It is opening. It always shows some time. Okay, so this is what I'm increasing the text size. So can you see? Now I'm going to verify it. Verify is a simple function which tells us whether the code is correct or not. But it does not tell us what the mistake is. You know, computer has intelligence, but not as we have. This is why it just tells whether the code has some mistakes or not. But what we should we change? It cannot tell us that. So sketch done compiling. Done compiling nothing means that it has compiled the code or nothing but read the whole code and has found no mistakes. This is why. First we introduce a connection, then we classify it as output. If it is a sensor, we can classify it as a input, and then in using digital write, we switch it on and then we switch it off. Sorry, we keep a delay of 1500 seconds, then we switch it off, and then again we keep a delay of 1500 milliseconds, and as a loop it will again repeat itself and switch on after 1500 milliseconds. Isn't it interesting? You can try your itself. You can download the Arduino IDE beta version, as I'm going to share the link in the description below, and then it's amazing, isn't it? So I'm closing this, and I hope you liked it, friends. And for my next tutorial, please don't miss. I'm going to share my next tutorial tomorrow. Bye bye.